So let's continue with the first question, that is prove that root 5 is irrational. We are going to prove this by contradiction method or indirect method. So let me tell you what is indirect method. Everybody knows that sun rises in the east. So in contradiction method, okay, what we do in contradiction method, we suppose opposite of this. To prove that sun rises in the east, okay, the direct method is just take the person and show that the sun is rising in the east. In the contradiction method, what happens? We assume the opposite of that. Opposite means we assume that sun rises in the west. Okay, this is called contradiction method, and later on we will prove that sun doesn't rise in west, so we can say that it rises in east. This is the meaning of contradiction method. So in contradiction method, we suppose the opposite of something. So here we are with a question now. In this question we have to prove that root 5 is irrational, so I'll assume the opposite, that is root 5 is rational. Keep in mind the co-primes and also the theorem. We are going to use that here. So we'll suppose that root 5 is rational. Hence every rational number, so if I suppose root 5 is rational, then every rational number can be written in the form of p by q or a by b. So root 5 can be written in the form of a by b, okay, where a and b are co-primes, because we never leave any fraction in non-simplified form. Like I cannot leave 4 by 6 like this. I write it as 2 is 2, 3 is this is the correct way, okay, of writing. So we write every fraction in simplified form. So what this a by b has to be? This a by b has to be co-primes, okay. All simplified fractions are co-primes because they cannot be further divided. So no common factor other than 1. You can see 2 and 3 are not further divisible. So a by b, in a by b, a and b are co-primes. Now this co-prime concept is very important here. Our whole theorem is based on this one line, okay. So we assumed that a root 5 is rational, so root 5 can be written in the form of a by b, where a and b are co-primes, means they do not have any common factor other than 1, okay. Now let's continue. So I'll write root 5 is equals to a by b, and if I cross multiply b here, it becomes root 5 into b is equals to a. Then squaring on both the sides to remove the square root, I'll get root 5b whole square is equals to a square. So square and root gets cancelled here for 5, and b square is equals to a square, and this 5 I take in the denominator here, okay. So this becomes b square is equals to a square by 5, okay, a square by 5. So here I'll use the theorem. I can say 5 divides a square, okay. So when a square by 5 I am getting, I can say 5 divides a square, the theorem which I explained you. So 5 divides a square, so I can say 5 divides a also. Yes, so this is the theorem which you can see here. If p is a prime number and p divides a square, then p divides a also. So I can say that as 5 divides a square and it is giving you some number like b, okay, there are some integers, then I can say, so 5 shall divide a also. So when 5 divides a square, 5 divides a also. We assumed a and b are co-primes, okay, but you see 5 is dividing a here, okay. Hence we can say that a by 5 is equals to c. See, where c is some integer. When 5 divides a, then I can say you get some integer, say c. So I can say a is equals to 5c, okay. Now I'll substitute this a is equals to 5c. Understand this one problem perfectly. Then only the number changes. In place of root 5 you can write any other number and prove it. So listen carefully each and every step. Okay, this is a theorem, so it may be confusing for you, but you can understand it if you concentrate. So I am taking a is equals to 5c because 5 divides a. Okay, if 7 divides a, I take a is equals to 7c. Okay, if 2 divides a, I take a is equals to 2c. So where c is some integer, so I am taking a is equals to 5c. Let's continue. A is equals to 5c. I'll put in equation number 1. I'll name this as equation number 1. Okay, this is our equation number 1. So I'll substitute that in equation number 1. Okay, so substituting a is equals to 5c in 5b square is equal to a square. In place of a, I'll write 5c, so this becomes 5c whole square, and that becomes 25c square. And if I cancel this, 5 1 times and 5 5 times is 25, so I get b square is equal to 5c square. If I can again write b square by 5 is equal to c square. So again I apply the theorem here. 5 divides b square, it is giving you c square, some number. So 5 divides b square, so 5 also divides b, so 5 divides b also. Finally we got 2 points here, that is in equation number 1. Don't name it as equation number 1 because already we named here as 1. Okay, just take it directly. I said take this one as equation number 1. You can leave it, you can name it as, just you can take it directly. So in the first equation we got 5 divides a. Okay, what did we assume? A and b are co-primes, means they are not further divisible, or they have only one as common factor. Yes, but here we can see 5 divides a, and in the second equation you can see here 5 also divides b. So what do you say now? Are a and b co-primes? No, because both a and b are divisible by 5. This is also divisible by 5, b is also divisible by 5. So 5, hence 5 is a factor of a and b, I can say, from 1 and 2. So a and b have a factor of 5. So a and b are not co-primes. Yeah, a and b are not co-primes. So what do you say? Our assumption is wrong. What we assume, that a and b are co-primes, we assume that root 5 is rational, so that is wrong. Like our assumption was wrong. Like I said you one example, that sun rises in the west, so it did not rise in the west, so our assumption was wrong, so it rises in the east. So we write, hence our assumption is wrong. By contradiction, root 5 is irrational. Hope it's clear to you all. It may take some time for you to understand it. Watch the video again and again if you have any doubt. Okay, and after you understand this, you can try these 3 questions on your own. And I want all the students to complete their works on time to avoid any problems in future, because when schools reopen and if your works are incomplete, then you will not be allowed in the class, then you will be completing the works, we will be revising for board exams, and you people will be completing the works. That will be of no use. So it's my personal advice to you all to complete your works, keep your works complete, and submit it regularly. Thank you.